This is the 4.5, 4.6, 4.9 review problem number 3. The instructions say to draw a direction field for the function f of x equals 2 plus x squared under a square root minus x. Use it to draw the antiderivative f that satisfies f of 0 equals 1. All right, well, first of all, I want to remind you of the relationship between f of x and its antiderivative capital F, right? And that is that the y values on little f of x are the slopes on capital F of x, right? It's antiderivative because, thinking in the other direction, if we have a function and we know the slope at a point, the slope becomes the y values on the derivatives. So therefore, the y value on little f would be the slopes from its antiderivative, capital X. So what we need to do here basically is we need to build a table of values using our given function f of x. And for x values, I'm just going to be thorough here. So I'm going to go from like -5 to 5 on the x-axis. And this would be a really great time to use your graphing calculator and use the table feature of the graphing calculator, because then all you have to do is type the function in once, type in all of these x values, and it will calculate all your y values for you. So I'm going to show you exactly how to do this. We've done this before, but it's just been a while since we've used this function. So it's good to be thinking about these things and keeping them fresh, because this is a skill that you might want to use on the AP test. So we go to y equals, and we want to clear out anything that we have in there. And we're going to type in our function, which we have the square root. And then underneath the square root, we have 2 plus x squared. And then make sure that you arrow out of your square root, and then we have the minus x afterwards. Okay, so now our function is in y1. So now we are going to go to second level table, which is above the graph key. So second level table. And I can type in any x values that I want, and the calculator will plug them into that y1 equation for me. So I'm going to do my x values in my table. -5, -4, -3, -2, -1, 0, 1, 2, 3, whoops. 3, let's try that again, not 23, 4, and 5. Okay, so these are the values that I am going to write on my paper in my table. So I'm going to go ahead and record those. We have 10.2, 8.2, 6.3, 4.4, 2.7, 1.4, and then we had 0.7, 0.4, 0.3, 0.2, and basically still 0.2. Okay, so our slopes start out very steep and they get more and more shallow as we go. So now I am going to use these f of x values, because remember, these f of x values, whoops, these are the slopes on my function, my antiderivative function, capital F of x. So I'm going to go ahead and I'm going to put some tick marks here on my axes. So -1, -2, -3, -4, -5. Whoops. And I'm going to put some values on my y-axis as well. And those just kind of help me. I do a lot there because those just kind of help me as I'm drawing my slopes, kind of envision how steep my slopes need to be in each location, right? Because, for example, when x is -5, my slope is 10.2, right? So I'd be going up 10, right 1. So that's like a really steep slope. So if you can imagine that, I'm going to do my very best to draw the steepest slope that I can draw here without making it look like a vertical line. But basically, my slopes at -5 are very steep. And then I go down to a slope of 8.2, so still quite steep, but just not quite as steep as 10.2. And then I'm at 6.3, so again, I'm getting, this is very approximate here, but I'm just trying to get less and less steep as I go. And then 4. And then 2.7, which is about 3, so just, again, slightly less. So I'm just getting more shallow as I go. And then at 0, I'm at 1.4. And then I drop to 0.7, so again, just getting more shallow here. And then 0.4. 0.3. And again, it gets kind of hard to discern the difference, but just do your best to try to make it look like there's something different going on. And I'm going to erase those accidental marks I had there. And then at 4, I'm at like 0.2, so a little more shallow here. And about the same slope here at 5. Okay, so now the last step to drawing in my antiderivative, capital F, is that I need to use that initial condition that I was given, and that was that f of 0 is equal to 1. So I know that my graph has to pass through the point when x is 0, y is 1. So that is the point right here on my curve. So now from that point, I just follow the slopes of my segments as I draw my curve. So it's going to look something like that and something like that. And that's it. We have just used our direction field to draw the antiderivative f that satisfies the function f of x with the initial condition capital F of 0 equals 1. So this would be capital F of x, our approximate graph.